Alright, relative motion, the next topic. Now, relative motion is actually an application of vectors. So, you can understand this topic easily if you are very good at vectors. Alright, the first few minutes of this video will explain to you how to understand and how to take relative motion. Once that is understood, you can continue with the other topics. Alright, so let's talk about what is meant by relative motion. Relative motion is nothing but the relation between the observations made by any two observers. Alright, the relation between observations made by any two different observers. Okay, now let's say this is an object. This is the object P, let's say. Let's talk about the position of object P with respect to the observers S and S dash, or let's name them A and B for the sake of convenience. Okay? Alright, now the position vector of P with respect to A is this one. Alright, this is the position vector of P, that is R of P with respect to A. Similarly, the position vector of P with respect to B is this. This is R of P with respect to B. What's the relation between the two? You will see the third vector here describes a complete closed triangle, and if you understand what it means, this is the position of A with respect to B if you go in this direction, and had you gone in the opposite direction, it would have been R of B with respect to A. Alright, R of B with respect to A. Alright, so let's just take R of A with respect to B here, and if you use the triangle law, the polygon law of vector addition, you will realize that R of A with respect to B plus R of P with respect to B is equal to R of P with respect to A. Now, understand this. You can see from here, this is R of B with respect to A, not R of A with respect to A. This is the position of B with respect to A. So this thing here will just be R of B with respect to A. Alright. Now you will see in this relation that the observer A can find the location of B also and the location of the body as well. You can see the location of body is this and the location of B is this. Right? Whereas B only has one position vector from it, which is position of the body. We define A as the lab frame. What is a lab frame? A lab frame is that frame of reference that will observe the location of the object as well as any other observer that is observing the object. In this case, it's P. Alright, so A is the lab frame here. Alright, so just take a look here. Take a look here. So just take a look at this equation here. We can modify it. The position of the particle as seen by B is equal to position of the particle as seen by A minus position of the observer as seen by A. Very simple equation. This equation tells you that okay, take a look here. This equation tells you that if you want to find the relation between the observation made by an observer and your observation, which is the lab frame observation, all you have to do is follow this equation. Now let's simplify these equations here. Let x be the position. So the position of A with respect to B is equal to the position of A minus the position of B. Now this A and B are not two different observers, neither are they two objects. Alright? Understand. If let's say there are two objects A and B, and both these objects can observe the location of each other, then in that case the location of B as observed by A, the location of B as observed by A is written as XBA, and the location of A as observed by B, location of A as observed by B will be given by this relation. Alright, a very fundamental and important relation. X of A with respect to B is equal to X of A minus X of B. Differentiate it once again, and we get velocity of A as seen by B is equal to velocity of A minus velocity of B. Got it? Very important. Differentiate once again. Acceleration of A with respect to B is equal to acceleration of A minus acceleration of B. Alright, and as you can see, all these relations are vector relations. Alright, so subtracting them means using vector methods of subtraction. Okay, very important. Now, let's see how to solve problems from this. The first case is pretty simple. Let's talk about the velocity of rain as observed by a walking man. This is a very important question, but very simple one. The question says that a man is walking horizontally. A man is walking horizontally with certain velocity Vm, and the rain is falling. Vr is falling, let's say at some angle theta, and we have to understand what is the angle with the vertical at which the man should hold the umbrella. Now I have not assumed that the rain is initially falling perpendicularly. I have already assumed that it's falling at some angle. The concept is that the man should hold the umbrella in the direction in which he observes the rain to fall, right? Isn't it so? So all I have to do is find the velocity of the rain with respect to man, which will become equal to velocity of the rain minus velocity of the man, right? So if the first step would be to create this equation, figure out what should be subtracted from what according to these relations here. And please understand this diagram once, okay? I'll explain this diagram once again to you right now. You will see these are just three vector relations. Alright, the application of these vector relations is what gives us this equation. Alright, position of P with respect to B. Here I am assuming that B is some other observer. Let's assume that we are A. All of us are A right now. And let's say there is another person B which is also observing the screen right now. So if let's say I want to describe how does the second person observe the P, which is the screen, let's say, we will talk about our own observation of the screen minus our observation of the person. That is what it means. In other words, the position of a point with respect to an observer B is the actual position which is described by A, which is you, of the body minus the actual position of the observer. So I'll repeat the statement. Position of a body with respect to an observer is equal to actual position of the body minus the actual position of the observer. And isn't that what we have seen yesterday right now? The position of A with respect to B is the actual position of A minus the actual position of B. Once you understand this, it becomes easy. Alright, the next is this and the next is this. Alright, anyways, so this is your first step to understand how to create the equation. Once you figure this out, the next is to create the diagram. So how do you create the diagram? Take a look here. This is the velocity of the ray, the actual velocity of the ray. I have told you it is occurring at an angle. And this would be velocity of the man, but we want minus velocity of the man, right? So we have to go in the opposite direction. So this becomes the velocity of the man. And Vm. Finally, the answer would be velocity of the ray minus velocity of the man. This is the result. Velocity of the rain minus velocity of the man, which is velocity of the rain with respect to man. This is minus Vm. Got it? So this is how you solve problems in general. So this is step 2, and then you can use some geometry and you can get the result here. If let's say some angles and some other values will be given, there will be no need, so you don't have to worry about that. Got it? So this is your concept of relative motion. Similarly, let's say in a lift, acceleration experienced with the lift, which is known as apparent weight, g dash, will be equal to the actual acceleration, which is g minus the acceleration of a. Now when the lift is going downwards, both are in the same direction, so it becomes g minus a. But when the lift is going upward, this is lift downwards. When the lift is going upwards, g dash will become g minus minus a, which becomes g plus a. Lift up. Alright? So these are your concepts here. Alright? Next comes the crossing of river. And crossing of river is also easy. The thing is that you have to be a little careful with the diagram here. As far as crossing the river is considered, the velocity of the river is in this direction, let's say Vr. Alright? And the actual velocity of the boat will be the velocity due to which the boat is actually moving. Alright? Remember one thing, velocity of the boat in still water is the same thing as the velocity of the boat with respect to river. Why is that so? Remember one very important theory about relative motion. The observer always assumes itself to be at rest. The observer always assumes itself to be at rest. Now if the observer is assuming itself to be at rest, it naturally implies that if the river is the observer here in this case, then the river assumes itself to be still water, and hence these two are equal. Now if crossing the river is the concept here, then there are two types of questions which are more popular than the rest. The first is crossing the river in the shortest path, and the second is crossing the river in the shortest time. So first let's explore shortest path. Shortest path. So this here is the actual path, that is the shortest path. The shortest path. Alright, here the velocity of the river will be this one, VR. This is the actual velocity of the boat, and therefore this is going to be the velocity of the boat with respect to river, which is the velocity of the boat in still water. So nicely you can see that for shortest path, the velocity of the boat, the actual velocity, is less than the velocity of the boat in still water. It's a very important concept. Don't forget this diagram. Alright, this diagram is also very important here. Okay, once this is understood, the next concept is about shortest time. Shortest path, shortest time. So shortest time means that the body is moving with the highest speed, isn't it so? So if this, let's say, is the river, then this becomes the actual path, that is velocity of the boat. Alright, this thing here is the velocity of the river, and this distance traveled is known as drift. Distance traveled is known as drift. The velocity of the boat in still water, that is the velocity of boat with respect to river, will be this one. Velocity of boat with respect to river. This is your equation here. As you can see in this case, the actual velocity of the boat is more than the velocity of the boat in still water, which is the velocity of the boat in the river. Alright, so these are your two more important questions, and any other question also can be solved using the general method. Draw the diagram after writing the equation and then use geometry to solve the problem. Alright, so altogether this is your concept of relative motion. Of course there are many number of problems that you can get from this, so it's very important to practice. Now as far as your weightage is considered, you can get a maximum of 2 questions from relative. Alright, but the questions will be easy, so scoring marks, of course, as long as scoring marks is a priority, you should always attempt questions of relative motion because they are easy, they are not difficult. All you have to do is practice questions like these and make things easy. Alright, that's all, and this completes your kinematics part. Now circular motion is a topic that we'll be doing after we finish forces, because there are some concepts of friction and tension that are required there. Alright, okay.